Good evening, one and all. Welcome to today's live discussion session of the NPTEL course Water Supply Engineering. I am Reshma R, PMRF Research Scholar from Hydraulics and Water Resources Engineering Division, Department of Civil Engineering, IIT Madras. Let me share my screen. Hope it is visible to everyone. Okay. So let's start today's session. Question number one. The economic value of water is determined by option A, the willingness to pay for water for specific use. Option B, the willingness to pay any price for the basic minimum amount for survival. Option C, the recognition that water is an economic good. Option D, all of the above. So, how do we determine the economic value of water? On what basis the economic value of water is determined? You can type in the answers in the chat box. Okay. So the correct answer is option A, the willingness to pay for water for specific use. So after the basic needs are met, people would then buy water based on its price compared to other goods they might buy. So initially, when it is required for survival, people may buy for any price. But once the basic needs are met, people would buy water based on its price compared to the other goods they are buying. So, the economic value is actually the willingness to pay for water for specific use. So, according to Dublin Statement Principle 4, water has an economic value in all its competing use and it should be recognized as an economic good. So, commodity has an economic value means that the people are willing to pay for it. Only when people are willing to pay for it, we tell that that particular commodity has an economical value. So, when it is coming to water, it is an essential parameter for life, and when it is required for the existence or survival, people would pay any amount. But as I told, once the requirement is met, then only its actual economic value is defined. Question number two. An appropriate example of the non use value of water is option A, drinking and industrial use. Option B, irrigation and other agricultural use. Option C, recreation and amenities. Option D, biodiversity conservation. So, which among these is a non use value of water? So, an appropriate example on of the non-use value of water among the four options given is we have option A, drinking and industrial use, option B, irrigation and other agricultural use, option C, recreation and amenities, option D, biodiversity conservation. So the correct answer is biodiversity conservation, option D. So direct or indirect use values are the values that are derived from actual use of water. That is, for example, when we use water for drinking, irrigation, recreation, etc., all these direct or indirect uses denote direct or indirect use values. Option value is used to measure the value attached to future use opportunities. It may be use values or non-use values, but it is regarding the future use opportunity. And values that are not associated with actual use is non-use values. So the values that are derived from actual use is termed as direct or indirect use values, and the values that are not associated with actual use come under non-use values, for example biodiversity conservation. Okay. Question number 3: which of the following statements are true regarding the capital cost of a water supply project? Statement 1: large investments in asset renewal, replacement, and rehabilitation are included in the capital cost. Statement 2: capital cost of the project is usually estimated using the updated schedule of rates of the region or country. Statement 3: the cost of labor and materials used for setting up a new plant is considered a capital expenditure. So, which among these statements are true regarding the capital cost of a water supply project? Option A: none of the statements is true. Option B: all statements are true. Option C: only statement 3 is true. Option D: statement 2 and 3 are true. So, which of these statements are true? Okay, so the correct answer is option B. All statements are true. All statements mentioned here are true. So we'll see what is this expenditures about. So first we have capital expenditure or capex, and then we have opex or operational expenditure. So as we know, in any other as in any other uh, works or projects or business or anything, capital expenditure is nothing but the expenditure that we need to set up the project, that is to initiate the project, that is the total cost during preparation and construction of the system till it becomes operational. So that is, it includes designing, construction, analysis, everything prior to making it operational. So it includes designing and constructing fixed assets, for example, concrete structure, pump, pipe, meter, land acquisition cost, workforce, whether skilled or unskilled, logistics, all these payments comes under capital expenditure or capex. So these are not expected to recur for a significant period because it is the first time and for, like it is the one time payment kind of. Now, when we look into operating expenditure or OPEX, they are mostly recurring expenses. That is, for example, repair and maintenance cost, replacement cost, cost of energy, fuel, chemicals, materials. So, all these comes under operating expenditure. That is, expenses incurred for operating that particular system, that is operating expenditure. So this is recurring expense, whereas the capital cost is not expected to recur. So when we see the cost components of capex and opex, we can see that within capex we have design cost, procurement and construction cost. That is still setting up of the project, it comes under capex. Once it starts operating, then we have opex, that is fixed cost, variable cost, inspection requirement, other requirement, all these comes under opex. In the case of larger investments in asset renewal, replacement, and rehabilitation, we have one more term, that is CapManX, where it is capital maintenance expenditure. So, there maintenance expenditure is also separately mentioned in the case of larger investments. Otherwise, it comes under OPEX itself. Hope that is clear. So, now we'll see how to estimate this particular capital cost or capex. So, this actually depends upon the requirements of the system, the materials, technologies, etc., that are being used, duration available for the completion of the project, etc. So, all these factors are to be considered while estimating capital cost. So, usually, what we follow is the current prevailing market rates to consider the rate of each variable or parameter. So, for that, we have one book called Schedule of Rates, which is updated regularly by government departments, and then it will have the rate of individual components, for example materials, labor charge, then equipments, certain construction services or works, etc. But however, this may be different for each state. So each state will have a separate schedule of rates book, because depending upon the region, the cost of materials itself may vary, cost of equipments may vary. So each state or each state will have a separate schedule of rates usually. Okay. Question number 4. Option value of water is typically used to measure: option A, potential future use opportunities. Option B, regulative measures. Option C, fishery and aquaculture. Option D, none of the above. So, just in the previous question, we had explained what is option value, non use value, and use value of water. So, according to that, option value measures which among these? Yes, the correct answer is option A, potential future use opportunities. So, option value is typically used to measure potential future use opportunities, which can be either use or non use value. Both will come under option value. Question number 5. The price elasticity of water in a city consuming 25 million liter per day is minus 0.63. Determine the approximate percentage reduction in water consumption if the unit price of water is raised from 12 rupees per kiloliters to 15 rupees per kiloliter. So we are given with price elasticity of water, average consumption in the city, and initial and final unit price of water. We are asked to determine the approximate percentage reduction in water consumption. Option A, 12 percentage. Option B, 16 percentage. Option C, 30 percentage. Option D, 10 percentage. So try to solve this. Okay, so I have got answers as option B. Yes, the correct answer is option B. So here we are given that the consumption, average consumption in the city is 25 million liter per day. Price elasticity of water in the city is minus 0.63. Initial unit price of water is 12 rupees per kiloliters and final unit price of water is 15 rupees per kiloliters. So, consider that the percentage reduction in demand is minus X percentage. Then, the percentage change in price, we can see it as final minus initial by initial into 100, right? So it is 15 minus 12 by 12 into 100, which is 25 percentage. Now it is given price elasticity is minus 0.63. So we have the equation for price elasticity epsilon as dx by x by dp by p. Among this dx by, so we have this price elasticity is given already. And this price, change in price in percentage is 25. We just calculated that. So only x is unknown. That is change in water consumption or reduction in water consumption. So just resubstituting, we have x is equal to 15.75 percentage. That is 0.63 into 25. So which is approximately 16 percentage. Hope that is clear. Question number 6. If the percentage change in water demand in a city is larger than the percentage change in price, then option A, the price elasticity is negative. Option B, demand is considered inelastic. Option C, the demand is considered elastic. Option D, none of the above. That is, in the earlier equation, dx by x is greater than dp by p. Then what is the condition? Yes, the correct answer is option C. The demand is considered elastic. So if the percentage change in water demand, that is dx by x, is greater than percentage change in price dp by p, then the demand is elastic. So the price elasticity of water demand epsilon, as we saw in the earlier problem, it is given by dx by x by dp by p, where dx by x is the change in water demand and dp by p is change in price. So it is a measure of how responsive consumers are to change in price. That is, when price changes, how the demand changes. That is what is represented by the price elasticity of water demand. So normally the price elasticity will be negative because the demand curve is always downward sloping. That is, when the price of a commodity increases, not only water, when the price of a commodity increases, obviously the demand will go down. That is, the consumers will be purchasing that particular commodity at a lesser rate. So the tendency of the consumer to purchase or acquire a particular commodity will go down if the price of the same commodity increases, right? So if absolute value of epsilon is less than 1, then we say that demand is inelastic. That is, for example, if there's increase of 25 percentage in water price leading to 10 percentage reduction in the demand of water. That is, relative change in demand dx by x is less than relative change in price dp by p. In that case, we say that the demand is inelastic. In the other case, that is, if dx by x is greater than dp by p, or if absolute value of epsilon is greater than 1, we call it as demand is elastic. Question number 7. An effective mechanism to ensure or enhance the value of water in a modern, economically driven society is. An effective mechanism to ensure or enhance the value of water in a modern, economically driven society is. Option A, ownership of the people using the water services. Option B, regulation of the utility operators. Option C, proper economic pricing of water. Option D, all of the above. Yes, the correct answer is option D, all of the above. That is, water is a precious commodity, we know. So we must seek to put value to water. That is, we should enhance the water conservation, or we should reduce the consumption, and we should reduce the wastage. So, the mechanism to ensure this are, first one is ownership. That is, whenever a particular thing is owned by a person, they will have more willingness to preserve or conserve without much wastage. So, the first parameter is ownership. Then it is regulation. That is, regulating the utility operators, ensuring protection of the public goods. So all these again leads to conservation of water. Then pricing. If water is less priced, there will be a tendency to waste more water. But if the price is too high, or if it is within an acceptable value, then consumers will be more vigilant to reduce the wastage rather than in the case when the water is provided for free. So, ownership, regulation, and pricing are the three mechanisms that we require. Question number 8. An appropriate capital budgeting technique to evaluate the fund allocation feasibility in water supply projects is. Option A, willingness to pay. Option B, cost benefit ratio. Option C, internal rate of return. Option D, both B and C. Okay, so the correct answer is both B and C, option D. So, appropriate capital budgeting techniques used to evaluate the feasibility of fund allocation in water supply projects are cost benefit ratio, payback period, net present value, and internal rate of return. So, the economic evaluation of water supply projects, it includes reliable estimates of all the economic benefits and cost. So, for a project to be economically feasible, the benefit should overweigh the cost. So, in order to evaluate the feasibility of fund allocation, capital budgeting techniques are adopted. That is, benefit cost ratio, payback period, net present value, internal rate of return, etc. Question number 9. In which of these water tariff models, water revenue is independent of water use? Option A, uniform rate model. Option B, flat rate model. Option C, increasing block tariff model. Option D, both uniform rate model and flat rate model. So, which of these water tariff models represent the calculation of water revenue independent of the water use? Okay, so the correct answer is option B, flat rate model. So, in the case of flat rate model, a fixed charge is imposed on the consumers irrespective of what they consume. So, the water bill will be constant every month or um, during every period of charging, it will be the same. So, it doesn't consider how much the consumer have used the water, how much quantity the consumer have used up, it's not considered. So here we do not need a meter also, because we do not need to measure the amount of water consumed. So in the case of uniform rate or IVT models, they are based on consumption, and hence we need a meter to measure this consumption. So, in the case of flat rate model, water revenue is completely independent of the water use. So, there are different types of water tariff models. That is, it can be broadly classified into two categories, that is, flat rate model and volumetric rate model. Flat rate model is fixed rate or flat rate, whereas volumetric rate models are of different types, that is, uniform volumetric tariff, increasing block tariff, volume differentiated tariff, decreasing block tariff, two parts tariff, and seasonal tariffs. So we'll see one by one. So first one is fixed charge or flat rate. So as we saw earlier, whatever be the consumption, the price remains unchanged. That is, the price versus water consumption graph will be a straight line parallel to x-axis in the case of fixed charge or flat rate. So here the volume used is not at all considered, and the consumer will be paying a fixed amount either on a monthly basis or an annual basis, but it will be a fixed value. But this value depends upon the connection type, consumer type, number of connections that consumer is having, depending upon the country, depending upon the quantity of water available. All these are factors that define this particular fixed charge. So if in case where we don't have a metering system, where we don't have a option to measure the water consumption, the only available method is fixed charge or flat rate method, and this is very common around the world. So this is mainly found in places where there is abundance of water, because as we saw earlier, pricing is actually done to reduce the consumption as well as wastage. So if you do not need a reduction because of abundance in water, then we may go for fixed charge or flat rate method. Still, these are used in industrial countries such as Canada, Norway, UK, etc. So, the criteria for setting this particular value, mainly three factors we have to consider. First thing is income or ability to pay, that is consumer type. That is depending upon the residential property, depending upon the financial status of the people, we will be fixing a particular charge. That is, for high income people, it will be higher than the low income and middle income people. So, for industries and households, it will be different. Also, it depends upon the type of connection, that is, diameter of the including the diameter of the connection pipes. So, including the diameter of the connection pipes is a factor that we consider to fix this fixed rate or flat rate. So, this particular method has several advantages as well as several disadvantages. So, the primary advantage is that we do not need a metering system. So, we do not need to have an employee to go on from house to house taking the readings. So, it is easy to manage or administer. So, if properly differentiated depending upon the financial status of the people, then this particular method ensures affordability and it provides stable cash flow. But the problem is that it do not give signal of real cost of providing water and sanitation service. We may not be know we are not aware of the amount of water that is being consumed. There is no method to reduce water consumption, and it may happen that just because the financial status is high, just because the household is high, they might be charged more without even having that much consumption. So, in the long run, fixed charges do not generate revenue for future service expansion because we are not aware of the exact consumption, exact requirement. Nothing is made aware here. So, second method, that is volumetric rate models. First one, uniform rate method. So, in a uniform volumetric charge or constant volumetric charge, independent of the use, all water units are priced the same. That is, depending upon the consumption, they just pay the amount. So, total price and total water consumption are proportional. Price per unit consumption doesn't change. Even if I am consuming X meter cube of water or Y meter cube of water, per unit charge will not vary. It will be a fixed value. And it will not even change with the customer class or customer level. It will be a constant for everyone. So the prerequisite is that we need to have a metered connection for each consumers. So depending upon the consumption, multiplying that particular consumption into unit price, we'll get the uniform rate that is to be charged. So this particular rate sends a price signal to customer. That is, there is a water bill that is being generated. So naturally, there will be tendency to reduce the wastage or reduce the unnecessary consumptions. So this particular constant volumetric tariff or uniform rate tariff can be designed as single tariff or two-part tariff. So we can structure this particular rate in such a way that the unit price is low or high. If the unit price is low, the water billing will be less and vice versa. Also throughout the year we can change the unit price. Annual variation we can bring in. Utilities may also fix uniform tariff for certain class of consumers. For example, for industrial consumers and domestic consumers, we can keep different values. Like that also we can fix up. So another one is IBT, that is increasing block tariff scheme. I mean scheme. So increasing block tariff scheme or IBT scheme. In this particular scheme, it's actually a level wise rating method. So here the unit price will be charged depending upon the level of consumption. For different level of consumption, they will have a stepwise structure as shown in the graphs aside. So it's like a tiered pricing, stepwise pricing. So for each step or tier, the pricing will be different. For example, for the first block, it will be X rupees per kiloliters. Then in the second block, it will be some X plus 5 or X plus 10 rupees per kiloliter consumption. So this is like for each higher levels, the unit price will also increase. For each block of consumption, this will happen until the highest one. So this will enhance reduction of wastage, reduction of unwanted consumption, because it is sending a very strong signal to the consumers. The design principles are like the water block design is generally based on consumption pattern. So we need to design the number of blocks, the volume of water with associated with each block, and the price to be charged for each block. So usually it will have three blocks. One is lifeline block or social block. That is the essential minimum consumption for survival. That particular block is known as lifeline block or social block. Then we have normal block where it is average consumption based on marginal cost. So it will be a higher than the essential consumption, but still it is an average consumption. Then we have the third block, that is a high priced block set. That is, it is designed to finance the full cost of service. So it is like unwanted consumption or very high consumption kind of category. So the critical issue is that in some cases, IBT may have unintended effects on the poor people. Financially lower people may find difficulties in this type of pricing tariff. For example, if poor households are sharing a common point or connection, then obviously the consumption rate will be higher because multiple households are depending on a single connection. But since the tariff calculation is based on the increasing block, due to the higher consumption as a whole by the whole of the households, we'll have to consider the higher rates. So this will be creating difficulty for the poor households. So the advantage is that it ensures cost recovery. Poor households are provided with affordable water. It promotes water conservation. But the problem is, if it is a shared connection, it may cause issues to financially lower people. Also, the design and metering becomes complex. So, the next method is volume differentiated tariff or VDT. So, this is also similar to IBT or increasing block tariff. But here the difference is that once we reach the highest block, the price that we pay is last block price, not only for the water consumed but also for the previous units of water consumed. That is, the last block reached by the consumption will be determining the price per meter cube for all the previous water consumed. So that is like disappearing the first block. So it is also known as disappearing first block tariff. And it's actually unfair because once we reach the higher block, then all the calculation is based on that higher rate. So if we compare it with the increasing block tariff, it is not accepted by most because of this unfair structure. So next one is decreasing block tariff or DBT. So it is just opposite of increasing block tariff. That is, as the level of consumption increases, the volumetric rate decreases. So for the first block, the unit price will be much higher than any other block. So this we can adopt only when there is abundant source of supply. And this will provide a disincentive for reducing wastage of water. So actually this is not in use now in many places because the signal to conserve water is not properly transferred to the consumers. But this is still being used in some communities of America, Canada, etc. But only problem is we need to ensure abundant source of raw water supply there. So now then we have two part tariff and seasonal tariffs. In the case of two part tariff, it will have a fixed charge component, in addition to which we have a variable charge component as well. So this variable charge component depends upon the consumption by the consumer. So the fixed part is actually the cost of construction, production, administration, and the variable charge part is according to the water use. So that is why it is called two part tariff. It has two parts, one fixed and one variable. Then we have seasonal tariffs. This is actually season dependent tariff. That is, depending upon the season, the charge will vary. For example, if it is a peak season, for example, summer. In case of peak season, like summer, when the water requirement is more, Price will also be higher so as to restrict the unnecessary usage. So according to the weather condition season, the price will increase and decrease. Higher price will usually occur in summer months. So that's what is shown in this particular graph. During the peak consumption months, it will be higher rather than on the off peak. So altogether we had flat rate method, uniform volumetric method, increasing block rate and decreasing block rates, volume differentiated tariff, etc. So within this uniform volumetric rate we had two-part tariff and seasonal tariff. Okay. So this is just a comparison between different methods. So here if we see among these, except flat rate and decreasing block rate, all others sends a conservative signal to the consumers. Implementation is easy for flat rate because it doesn't need a meter itself. And the revenue depends upon the water use for all the parameters, for all the methods except flat rate method. So hope all the methods are clear. Moving on to the next question. Question number 10. The social or lifeline block in an increasing block tariff structure represents option A, the volume of water corresponding to essential minimum consumption, option B, average consumption defined on the basis of marginal cost, option C, price block designed to finance the full cost of the service, option D, all of the above. So we have seen this earlier when I was explaining the increasing block tariff structure. So what does social or lifeline block represent? So we have seen that increasing block tariff structure generally consists of three blocks. So in that, what does social or lifeline block represent? Okay. So the correct answer is option A, the volume of water corresponding to the essential minimum consumption. So the social or lifeline block is the first block which represents volume of water corresponding to essential minimum consumption. Question number 11. Efforts to phase out the decreasing block tariff method in several countries are primarily because option A, DBT penalizes the economically weaker sections of the society. DBT is a highly complicated method to implement. Option C, DBT provides no cost signal or incentive to reduce water wastage. Option D, none of the above. This also we have seen when I was explaining decreasing block tariff method, why it is less adopted these days. Okay, so the correct answer is option C. DBT provides no cost signal or incentive to reduce water wastage, because in DBT it is like decreasing block. That is, for the first block, the cost unit price is much more than any other blocks. With increase in block level, the unit price is decreasing in the case of DBT method. So it is not providing any cost signal or incentive to reduce water wastage. So that is, efforts to phase out the decreasing block tariff method in several countries is primarily because it provides no cost signal or incentive to reduce water wastage. Coming to question number 12, which of the following statements are not true regarding the constant volumetric tariff model? Option A, all water units are priced the same independent of the use. Option B, consumers pay proportionally to their to their water consumption. Option C, the unit price of water increase at a constant uniform rate within each consumer class. Option D, consumers must have a meter installed for implementing the tariff model. So which all are false regarding constant volumetric tariff model? So the correct answer is option C. The unit price of water increases at a constant uniform rate within each consumer class. So that is the false statement. So for the constant volumetric tariff model, for all the consumer class, it will be the same. The unit price is independent of the use and consumer class, and it does not change with any water class or. So all consumers need to have a metered connection for implementing volumetric tariff model. Question number 13, match the cost with appropriate components. So in column 1 we have A, supply cost, B, economic cost, C, full cost. In second column we have one, economic cost plus environment externalities. Second one, capital charges plus operation and maintenance cost. And third one, opportunity cost plus economic externalities plus capital charges plus operation and maintenance cost. So match the following. Option A, A2, B1, C3. Option B, A3, B2, C1. Option C, A2, B3, C1. Option D, A1, B3, C2. So match the cost with appropriate components. Yes, so the correct answer is option C, A2, B3, C1. That is, full supply cost is equal to capital charges plus operation and maintenance cost. Full economic cost is equal to opportunity cost plus economic externalities plus capital charges plus operation and maintenance cost. And full cost is equal to opportunity cost plus economic externalities plus capital charges plus operation and maintenance cost plus environmental externalities. So whatever we have mentioned the equations that is clear from this particular figure, that is, if you see, full supply cost is the sum of capital charges and operation maintenance cost. Full supply cost plus opportunity cost and economic externalities will give you full economic cost. Full economic cost plus environmental externalities will give you full cost. Question number 14. A city is charging households for water consumption based on a four slab increasing block tariff structure with tariffs as rupees 5 per kiloliters for 0 to 5 kiloliter per month, rupees 10 per kiloliter for 5 to 10 kiloliters per month, rupees 15 per kiloliter for 10 to 15 kiloliter per month, rupees 20 per kiloliter for greater than 15 kiloliter per month. The monthly water bill for a household consuming 25 kiloliters of water in a month would be. So please try to calculate this and type in the answer in the chat box. So I shall give you 3 minutes time. I think that is sufficient. Please let me know if you want more than that. Okay, so I have got one answer as 350. So let's see. Yes, the correct answer is 350. So we are given that the charging method, water charging method adopted in this particular problem is four slab increasing block tariff structure. So we have four slabs and the tariff adopted for each slab is given, like for 0 to 5 kiloliter per month consumption it is rupees 5, then rupees 10 for 5 to 10 kiloliter per month, 15 per kiloliter for 10 to 15 kiloliter per month consumption, and for a consumption greater than 15 kiloliter per month the amount is 20 per kiloliter. So the monthly water bill in the case of a 25 kiloliter consumption will be, based on IBT model it will be, for 0 to 5 at rupees 5 per kiloliter, for 5 to 10 at rupees 10 per kiloliter, for 10 to 15 at rupees 15 per kiloliter, and for 15 to 25 at rupees 20 per kiloliter. So we have to divide this particular 25 kiloliter consumption in steps, that is in blocks. That is, we have four blocks. So 5 kiloliters into 5 rupees per kiloliter, then again another 5 kiloliters consumption, then again 5, and then the remaining 10 because we have four blocks. So that is rupees 350. Next question. Cost of operation and maintenance of a water supply system serving 50,000 households in a city was worked out as rupees 45 lakhs per month. The utility is using a uniform tariff model to recover the entire operation and maintenance cost. If a household consuming 15 meter cube water in a month pays 120 rupees water bill in the month, what would be the tariff under a uniform tariff structure in rupees per meter cube? So this is a meter cube. So please solve this. Okay, so do you need a little more time because I'm not seeing any answers in the chat box? Uh, should I wait or should I explain? Okay, I think I got one answer in the chat box. Yes. So I'll explain how to do this. So the correct answer is 8. So it's given that cost of operation and maintenance is rupees 45 lakhs per month and total of 50,000 households is being served. The model adopted here is uniform tariff model. So, and also it is mentioned that for 15 meter cube water consumption in a month, the water bill was 120 rupees. So, uniform tariff rate is given by amount paid by total consumption. So, that is 120 by 15. That is the bill that is arrived for a 15 meter cube consumption, or the amount that we have paid for a 15 meter cube consumption divided by the consumption, that is 120 by 15, which is rupees 8 per meter cube. Hope that is clear.
Uh, but as for the material, uh, in a problem I found it is written that amount to be recovered divided by total consumption.
Yeah, amount to be recovered is the amount that is being paid, right?
No, is it? Can it be done in this way that total amount is 45 lakhs per month as per the question, and total amount consumed by 50,000 household is 50,000 into 15, because in last to last class there was a confusion regarding this type of question actually.
Okay.
Will you
Um,
please cross check it, because it is given amount to be recovered by total consumption. So total amount here, as per the question, it is 45 lakhs per month,
uh,
and total that is total consumption will be, if it is given
mhm.
one household is consuming 15 meter cube, so
Yes.
total 50,000 household,
Hmm.
so total consumption will be 50,000 into 15. So if we divide, then we get 6.
Okay, so the
But
thing is actually what I understand from the term
mm,
amount to be recovered is that amount that a consumer have to pay, or the amount
mm,
that the agency have to recover from the consumer. Like it's kind of payment. So as far as my understanding, this is how it is to be done. So maybe I can check in the check
uh,
once in the
okay, you go through the material. Next class maybe.
because this is the last class, I guess.
Oh,
So that's why I
okay,
will
okay.
just scroll on the material now itself because otherwise it will be a trouble for you also for the exams.
Yes, yes, and that is why I also faced difficulty while solving assignment of lecture 12,
Okay, okay. So let's
particularly.
see that
Yes.
once. Mm, excuse me. So that was uniform rate
Uh,
method.
do you have the material? You can refer page 33 of that PDF. Week
Uh,
12 material,
um,
page page 33.
yeah, I think that I just crossed that number. Setting order tariff price. If you see that somewhere, please stop me. I'll. Um, is it 30? Okay, maybe the page
Page
number
30.
you told. I have to.
Page number.
Yeah,
Yes,
yeah, yeah.
page number.
1 second. So I think uniform rate 25 somewhere here it should be tariff. Um, okay, you are mentioning about one problem, right? Here,
Yes.
this problem you're mentioning.
No, before this one, I think. Problem before. Yes, yes. Here, you see uniform rate tariff
Hmm.
equal to amount to be recovered in a month divided by total consumption. In this way, it is solved.
Okay, so there's a confusion there. Does it fish 36 crore by 12? Where is the question? Let me see. Town 1.5 lakhs water connections is having monthly water consumption pattern as under water utility decides to recover. See, there is difference actually. The thing is here the let me check the question. Yeah, so this is like what would be the tariff under a uniform tariff structure. It's not about the amount that is being recovered, but in the question in this problem, it is clearly mentioned that the water utility is deciding to recover the annual operation and maintenance cost of this particular amount from the user.
Yes. Mm.
So that is like in this case the agency is deciding that okay, we have spent 36 crore amount for operation and maintenance cost on an annual basis. Now we'll recover that amount from, that is the recovery means we are replacing the expenditure that we had by collecting an amount from the users. So in that case we need to finally collect this particular amount, right? So
Yes.
there they are using two types of models. It's not for metering the consumption of the consumer, but it is for recovering the operation maintenance cost that they have met. So in that case, they have to adopt this particular equation amount to be recovered.
Okay.
But in our question,
Uh,
the thing is there, yes, they have mentioned the number of household, they have mentioned the maintenance cost. Okay, but here also it is using a uniform tariff model to recover the entire. But they're asking the tariff under a uniform tariff structure, and here, what is being asked? So just the water tariff that you follows. No, if that logic also. Now even I am confused. Uh, okay, so I think this water tariff design. Mm, okay.
okay, if while uploading this solution will be uploaded na today's class
Yeah, yeah, sure.
whatever. So while uploading also, if you can cross check and then upload also, we can understand.
Yeah, yeah, sure. I'll just do that because this will be a confusion otherwise. Yeah, if
Yes, yes.
problem comes
And
very
in
hands.
below that problem in NB, one point you can mention so that we can understand in this way
Yeah,
we have
sure.
to
I'll
solve.
I'll just
Uh,
explain it in this next slide. I'll keep an explanation as well.
yes.
Sure, sure.
Okay. Thank you.
So yeah. So any other doubts you have? Okay, I'll stop the presentation and then maybe we can address the doubts if any.
No, nothing else.
Okay, okay. All right. So okay. So all the best for the exams, upcoming exams. Thank you.
Thank you very much. Bye.
Mm.